Hello, welcome back. So in this part, we are now going to discuss about the analysis of trusses. Well, analysis of truss, it contains some of the aspects. So first aspect that we will discuss is the assumption. What are the assumptions that we generally follow to analyze the truss? Now, before we discuss about this, first of all, I would like to say that if we want to construct a truss structure, then for that, what we have to do is we have to design the truss. Now, designing the truss means we have to find out the size of the member which will be used to make that truss. And to calculate the size of member, we need to understand what is the force in that particular member. So one member may have less force, another member may have more force. So if a member is having less force, then the size of member will be less. And if a member is experiencing more force, in that case, we have to size the that member as the size will be large. So here we are talking about the analysis of trust. Now, analysis of trust means calculating or determining the forces within the member. Then only we can design that member. So, to calculate the forces in that member, we follow some rules and we have some assumptions. So, what are those assumptions that we will see now? So first assumption is all the joints interconnecting the member are pin joints. So like this is the truss. So these are the members are connected here. So these joints are the pin joints. Now pin joint, they are also known as hinged joint. Now, hinge joints are those joints which will not allow any translation, which means they will not allow any movement along the x-axis, along the y-axis, but they can permit rotation. So hinge joint are those joint which will not allow any movement of the member along the x direction or along the y direction. But the joint can rotate like this or like this. So which means if there is a rotation, if there is a rotation permitted, which means the moment will be zero here. So that is the hinged joint. So all the joints which are there in the truss, they are considered as the hinged or pin joint. So that is the first assumption. Now this is actually the assumption because these joints in actual, these joint may be connected using the bolts or using the welding. So in that case, they may be rigid, they may not be hinged, but what we are doing is we are assuming here that all the joints will be pin jointed. So that is our first assumption. Now pin jointed means moment is free, rotation is free. So rotation is allowed, but movement along x-axis and y-axis is not allowed. Now, the second assumption is the loads are all concentrated load and they act exactly on the joint. So all the loads that will be acting on this truss, they will be acting along the joint or at the joint only, like this. So you can see this is the load which is acting on this joint and this is the load which is acting on this joint. So if the load is coming on the joint like this, then it is okay. But if we apply load like this on the member, then it is not okay. So load will always be coming on the joints of the truss. Then the third assumption is all the loads are applied in the plane of the truss. So all the loads should be in the same plane as of the truss. So for example, if the truss is along the XY plane, if this is the XY plane, then load will also lie along the XY plane. This load will never lie in other plane. If it lies, then we cannot design the truss. So truss, I mean the load plane should match with the truss plane. So these are the three assumptions, and based on this, we analyze it. Now, furthermore, if we discuss another aspect of the analysis of truss, so that aspect is truss members are considered as two force members. They are considered as two force members. So as I said here, each truss member will act as a two force member, and therefore the force acting at each end of the member will be directed along the axis of the member. Now, first of all, we will understand what is two force member. Well, the member two force member is a member where force is acting on 2 points. For example, this is a bar. Now, if one force is acting along this, and if another force is acting along this, then this force can be considered as two force member, provided it satisfies the equilibrium condition. So those equilibrium condition is, first is force equilibrium, and second condition is moment equilibrium. It should also satisfy the moment equilibrium. Now, force equilibrium means the summation of the force should be zero. Now, moment equilibrium means moment of force should be zero. Now, if I apply force on this member along its axis, so if this is the main axis of the member, so if I am applying this force along this axis, so one force is this one and second force is this one. So to have force equilibrium, both of these forces should be of same magnitude and should be in the opposite direction. Then only force equilibrium can set up. Because if this force is along this direction, then to negotiate this force, we should have force in opposite direction with same magnitude. So that is the first condition of two force member. Second condition is moment equilibrium. Moment created by the force should be zero. So now you can see these two forces are actually the concurrent force, and therefore their line of action is in the same line. So their line of action is same, and because of that there is no perpendicular distance, there will be no rotation. So therefore moment equilibrium will also set up. By chance, if I have done one force here and second force here, in that case, moment equilibrium condition may not occur, or force equilibrium condition will not occur. So technically we can say that we are applying two forces on 2 points, but we are applying such that force equilibrium and moment equilibrium, they are not setting up if we apply that force here. So we have to apply two forces such that force equilibrium and moment equilibrium can set up. So those members are known as two force member. So now talking about the truss member. So truss members are considered as the two force member because in the truss load is applied along the joint, and from the joint further load passes along the member along their length. So you can see, say these are the two members. Okay, I will make an example. Say for example, this is the truss and load is coming on this joint. So because of this load, this member and this member, they will experience the effect of this load, but they will experience, I mean, the load will transfer along their length. So in that manner, the deformation of these member will be along their length. So that deformation can be in the form of stretching, or that may be in the form of contraction. So therefore, the nature of this two force member is, I mean, the member can be either in tension or it may be in the compression. And because of this force, the member may stretch or elongate. So from these two ends, it may experience stretching like this, or it may experience compression like this. So that is why the condition of two force member, they satisfy, and that is why they are considered as the two force member. Now, because of this phenomena that I have discussed here, the member can be either in tension or can be in compression. So as I written here, if the force tends to elongate the member, it is tensile force, whereas if it tends to shorten the member, it is a compressive force. And in the actual design of truss, it is very important to state whether the nature of force is tensile or compressive. We need to state whether the force in the member, if it is compressive force or tensile force, because the member which experience compression, they are generally thicker member or they are generally heavy member as compared to the tension member. Tension member are more efficient than the compression member. Why? Because compression member may have another kind of deformation which is called the buckling. Because of this deformation, they can buckle like this. So they may not utilize its full strength. So that is why what we do is compression member are generally thicker. We make them thicker so that this buckling may not occur. So that is what I have written here. Compression member must be made thicker than the tension member because of the buckling effect. So this buckling effect is also occur in the column. So when we discuss about the column, we will discuss more about it. But just remember that the member which experience compression, it may have buckling effect. Buckling effect is basically this bending effect. It may bend like this. Now, another aspect of the analysis truss is the methods. So there are basically two analytical methods which we generally use to find out the force in the members. And those two methods are method of joint and method of section. So in this lecture, we will discuss in detail about the method of joint and the second method of section. We will discuss this in the next lecture. So we will continue our discussion in the next part. Thank you.